Hi, welcome to Chapter 6. Let's talk about norm-referenced reliability and validity. Objectives: discuss the concepts of reliability and validity, identify and calculate reliability and validity, understand the relationship between reliability and validity, and evaluate typical evidence of reliability and validity in human performance. The concepts of reliability. Reliability relates to the consistency of repeatability of an observation, the degree to which repeated measures of the same trait are reproduced under the same conditions, also described as consistency, dependability, stability, and precision. The concepts of validity and relevance. Validity is the degree of truthfulness of a test score. It's dependent on two characteristics, reliability and relevance. Relevance is the degree to which a test pertains to its objectives. Concepts of objectivity. Objectivity is a special kind of reliability, also known as an inter-aidor reliability. Objective tests, multiple choice, differ from the subjective test, essay, in that they are less biased or not as easily influenced regardless of the rater. Reliability. A Pearson product moment, PPM Correlation coefficient in Chapter 4 is used to provide evidence of a test reliability. Observed, error, and true scores are theoretical concepts that will help you understand the concepts of reliability. Let's look at the systolic blood pressure recordings for 10 participants. Observed, error, and true scores. Each person's observed score is the sum of the true score and error score. True score theoretically exists, but it is impossible to measure. An error score results from anything that causes your observed score to differ from your true score. Reliability. A test is said to be reliable to the extent that observed score variation is made up of a true score variation. Theoretical conclusions of reliability. Observed score variance equal true score variance plus error score variance. Reliability coefficients range from 0 and 1. A desirable level of reliability is a 0.8 or higher, and generally longer tests are more reliable than shorter tests. Calculating the reliability coefficient. Interclass coefficients based on PPM correlation coefficient, see Chapter 4, and the intraclass coefficients based on ANOVA, see Chapter 5. Interclass reliability, test-retest reliability, equivalence reliability, and split-halves reliability. Test-retest reliability. A single test is administered twice to participants. The scores of the separate test administrations are correlated using the PPM correlation coefficient. If the time between testing occasions is longer, the test-retest reliability is often called stability reliability. Here's setup performance for 10 participants. You can see Trial 1 and Trial 2, excuse me. Equivalence reliability. Two parallel or equivalent forms of an exam are given to participants. The scores in each exam are correlated using the PPM correlation coefficient to determine the level of agreement between the two exams. Or you can have split-halves reliability. Administering the same test twice or two separate tests may not always be the best option in practice. This form of reliability uses a single test to determine reliability by splitting the test into parts, odd questions and even questions. Odd even scores for 10 participants. Spearman-Brown prophecy formula. Longer test is more reliable, so we have to account for that using the Spearman-Brown prophecy formula. Interclass reliability. The interclass model allows you to estimate reliability for more than two trials. Interclass models also address the constant difference problem that can be seen in interclass models. Effect of a constant change in measures. Cronbach's alpha coefficient. Common interclass correlation model separates total variance into three components: people variance, trial variance, and people by trial variance. People variance is the observed score variance between participants. Trial variance is based on the variance across the trials, and people by trial variance is based on the fact that not all participants perform equally across trials. Here's calculating the alpha coefficient. You've got trial 1, 2, 3, and the total. Index of reliability, theoretical correlation between observed scores and the true scores, square root of the reliability coefficient. Standard error of measurement, SEM. It reflects the degree to which a person's observed score fluctuates as a result of errors of measurement. SEM is the standard deviation of the errors of measurement around an observed score. Factors affecting reliability, fatigue, practice, participant variability, time between testing, circumstances surrounding the testing periods, appropriate level of difficulty for testing participants, precision of measurement, and environmental conditions. Validity, content-related, criterion-related, or construct-related. Content-related, evidence of truthfulness based on logical decision-making and interpretation, also known as face validity and logical validity. Content experts, expert judges, colleagues, and textbook writers can serve as sources to validate instrument content. Your criterion-related is based on determining the relationship between a criterion and other measures used to estimate the criterion, also known as statistical validity and correlational validity. Concurrent validity is criterion is measured about the same time as the alternative measure, and your predictive validity is criterion is measured in the future. Examples of concurrent validity, you can see that right there, V2 max. You've got your submaximal cycle treadmill swimming, and then your non-exercise models, like what would be self-reported physical activity. Here's predictive validity, heart disease, success in graduate school, grade point average, or graduation status. And here's sources of criterion measures, actual participation, known valid criterion, expert judges, tournament participation, and known valid test. Construct-related validity, used to validate measures that are unobservable yet exist in theory. Evidence that combines logical content and statistical validity procedures. If in theory the construct is valid, then such and such should occur, associated with convergent or discriminant evidence. Construct-related validity is an example of known group of difference methods of construct validation. So a student who is poor at golf should score poorly on a golf test. Experienced golfers should obtain higher scores, and members of the golf team should score the best. Testing differences of means with ANOVA could provide construct-related evidence for the golf test. And here's the diagram of validity and reliability terms. You can see your objectives, reliability, relevance, comes down to concurrent or predictive. Here's your ANOVA, and then here's your Split-Halves test. Applications of the PPM correlation in reliability and validity. You can see your reliability, objectivity, equivalence, concurrent, and predictive all right there. Estimating agreement between measures. Bland-Altman method. Bland and Altman presented a method of estimating the agreement between two measures of the same attribute. Correlation is limited in its ability to detect the magnitude and distribution of the differences between two measures. Bland-Altman approach is based on the absolute difference between the measures and plotting those against the averages. And here's an example of the Bland-Altman method. So it's got your differences and then your averages there. Here's a plot of statistical blood pressure. Here's your modified systolic blood pressure data. You got your differences and your averages. And your Bland-Altman plot of statistical blood pressure. Here's your differences, here's your average, here's your plot. In summary, reliability, objectivity, and validity are the most important concepts. Reliability and validity results are not typically generalizable, and results are specific to the group tested, the environment of testing, and the testing procedure.